Dear students, in the previous class I have started finding economic order quantity. In that I have found how much to order. Okay. In this lecture I am going to continue the same problem to answer the following question. One is when to order and knowing what is the reorder point. So, the agenda for this lecture is how to use nonlinear programming for solving economic order quantity and to answer these two questions. One is when to order and what is the reorder point. If any inventory management problem we have seen in the previous class, see that it will be in x axis the time, in y axis is quantity. So, we have found in the previous class what is Q, economic order quantity. Now, we should know there may be different cycle, we may not know that. We should know when to order, right. We know quantity. Now, I am going to answer in this lecture when to order. And another one is if there is a lead time, what is the reorder point? Reorder point is, okay. So, suppose I have some quantity, say in the previous class we have found the value of Q is 1824. What will happen when the time increases, we will start consuming this 1824 quantities. So, it will keep on consuming at one point, right, we have to start order. So, that point what quantity we have to find out, that point is called your reorder point. Okay. That is we are going to find in this lecture. First I will solve this the EOQ model with the help of nonlinear programming. We know that the total annual cost is sum of annual holding cost and annual ordering cost. So, what is the annual holding cost? This average inventory Q upon 2 multiplied by holding cost plus number of orders multiplied by ordering cost. So, in our problem we found the interest rate is 25%, unit cost is $8. So, 0.25 multiplied by 8, so it is a $2 and the ordering cost is $32. The demand is 1,04,000. What is the formula for total cost? Q by 2. So, I am substituting the ordering cost. So, 2 demand divided by Q multiplied by ordering cost. So, when you simplify you will get Q plus 33 lakhs 28,000 upon Q. So, we have to find out this Q value. In the previous class we found economic order quantity is equal to 2D C naught by CH. We have derived this formula. C naught is ordering cost, CH is holding cost. So, instead of deriving this, we can use the idea of nonlinear programming to find out the optimal value of this Q. That is what we are going to do. So, I am going to open an Excel, I am going to write these equations, then I am going to find out the value of Q. Now, I am going to find out the optimal value of Q. We know the function for total cost Q plus 33,28,000 upon Q. So, Q is of my decision variables. Look at the objective function F7. See, in the F7 I have written this expression. What is that? So, the value of objective function is the Q, that is F5 plus demand 33,28,000 upon F5. Okay. Now, this expression is nonlinear. So, if I go to solver, go to data, solver. So, now it is F7 is my changing cell, F7 is my objective function, it is a minimization function, the F5 is my changing cell. So, we know that there should be a value of F by should be greater than or equal to 0. Here you have to select GRG nonlinear. So, when I click solver and you see the result, the value of Q is 1824. This is the exact value which we got using our EOQ formula. Now, I will go back to my presentation. This is the exact value of Q, right. The objective function value is 3648. So, what point we are taking from here is that any EOQ formula can be solved with the help of solver by using the concept of nonlinear programming, which we have studied in detail in our previous lectures. Now, we are going to find out when to order decision. As I told you in the previous class, this is assume that this is inventory cycles, assume that this is inventory cycle. So, we have got value of EOQ, that is a Q value. Now, we should know when to order. So, this answer we are going to get now. Now, that we know how much to order, that is the value of Q, we want to address the question of when to order. Okay. We know the x axis is the time, y axis is quantity. To answer this question, we need to introduce the concept of inventory position. So, the inventory position is defined as the amount of inventory on hand plus the amount of inventory on order. That is the meaning of inventory position. So, the when to order decision is expressed in terms of a reorder point, that is the inventory position at which a new order should be placed. What is the meaning? Suppose we have 1824, we will keep on consuming. So, it will reach a particular position. So, when the 1824 reaching a particular positions, we have to start ordering another cycle. So, that position is called your reorder point. Okay. You may ask, we can order once it reaches inventory 0, but what will happen? There will be a lead time for receiving any order. So, in advance we have to order, so that when the quantity reaches 0, we may get the order what we have ordered previously, so that there will not be any shortage, because here assumption is that we are not allowing for any shortage. So, that in advance we have to order. So, at point at which the inventory has to be ordered, is called reorder point. Now, there are some more informations about this problem we are going to study. The suppliers of this company guarantee a 2-day delivery on any order placed by the cold drink company. So, here the inventory, the lead time is 2 days. Hence, assuming the company operates 250 days per year, okay, the annual demand we know 1,04,000 cases implies a daily demand. What is a daily demand? The annual demand divided by number of working days. So, the daily demand is 416 cases. We know that the lead time is 2 days. So, what you have to do? We expect 2 days and multiply it by this 416 cases per day. So, this is 832 cases of cold drink to be sold during the 2 days. So, it takes a new order to reach the company's warehouse. Okay. So, it is like this. So, when the point reaches from 18,242, when the point reaches 832, then we have to make another order. How we got this 832? Because lead time is 2 days, per day demand is 416. So, when you multiply lead time and per day demand, that will give you the reorder point. That is what the answer we got, 832. So, in inventory terminology, the 2-day delivery period is referred to as the lead time for a new order, and 832 case demand anticipated during this period, that means during the lead time, is referred to as the lead time demand. Thus, the cold drink company should order a new shipment of cases from the supplier when the inventory reaches 832 cases. So, this 832 is nothing but your reorder point. Still we did not answer when to order. The when to order we are saying in terms of quantity. When the quantity reaches from 18242, when it is reaches 832, okay, we have to make another order. Here in terms of quantity, but I want to say in terms of time, when should I make the next order? So, that we are going to answer. So, for that for example, this problem can be solved by using a formula, reorder point formula. For inventory system, using a constant demand rate assumptions and a fixed lead time. Here also you remember the lead time also fixed and the demand rate also fixed. So, the reorder point is the same as the lead time demand. So, the reorder point is nothing but your demand during the lead time. So, for this system, the general expression for the reorder point is reorder point R equal to D, that is a demand per day, M is the lead time for a new order in days. We can say this as a formula to know the reorder point. Now, the next question is how frequently the order will be placed. We have answered when to order, but we did not mention the time. The time we are going to know by answering this question. What is that? How frequently the order will be placed. That means, we are asking what should be the timing for making the next order. Okay. The question of how frequently the order will be placed can now be answered. How? The period between order is referred as the cycle time. So, this is cycle time 1. Suppose if you order another thing, this is cycle time 2. So, here we got reorder point. So, this duration is our cycle time. Previously, we defined D by Q is the number of orders that will be placed in the year. Okay. So, how we got this number of order? D upon Q, Q star. Q star is the our this value. We can Q star, economic order quantity. So, 1,04,000 upon 184, there will be 57 times we have to make the order. So, 57 is the number of orders. Now, we can find out the cycle time. If the company places 57 orders over 250 working days, okay, it will order approximately every 250 upon 57 4.39 working days. So, this distance, now we got this distance. So, this distance is 4.39. So, every 4.39 times the company should make the order. Okay. So, the cycle time is 4.39 working days. So, the general expression for cycle time of T days is given by this formula, T equal to number of working days divided by number of orders. Okay. So, 250 upon 57 we are getting this 4.39. Now, the sensitivity analysis for the EOQ model. What is the meaning of sensitivity analysis? In the total cost expression, we have the annual holding cost and annual ordering cost. If the value of annual holding cost and the value of annual ordering cost is changing, how that will affect our economic order quantity. So, we want to know how robust is our model, that is EOQ model. That is what we are going to do with the help of Excel. So, even though substantial time may have been spent in arriving at the cost per order, we know that is a $32, that is the ordering cost, and the holding cost rate is 25% of the unit cost. Now, we should realize that these figures are at best good estimates. That means there is a chance for variability. Thus, we may want to consider how much the recommended order quantity EOQ would change with the different estimated ordering and holding cost. Okay. So, if the value of CH and CO is changing, the range of CH and range of CO, and how that will affect our value of EOQ. That is nothing but you can Q star. Okay. So, to determine the effect of various cost scenario, we can calculate the recommended order quantity under several different cost conditions. Now, I am going to explain how to use Excel for doing this sensitivity analysis. The demand I have taken 1,04,000 and the interest rate is 25% and the unit cost is $8 and the ordering cost is 32. So, in H7 to H10 I am going to change this interest rate. I am considering only two scenario, instead of 25, if it goes to 24, what will happen? If it goes to 24, you see the value of I7. So, if I keep the cursor on I7, you see the ordering cost is 192, previously it was $2, it is decreasing. The inventory holding cost is now it is $1.92 and instead of ordering cost 32, if I change 30, okay. So, now I am going to substitute in that formula. When I click K7, I have used our traditional formula, square root of 2D C naught divided by CH. So, now the ordering quantity for 1.92 holding cost and 30 ordering cost, the EOQ is 1802. So, for this 1802, what is the total cost? So, I am going to substitute this 1802 into my total cost function. That is what I have done it K7. So, you see the formula for L7, I am finding the total expression for total cost. So, average cost is K7 upon 2 multiplied by I7 plus number of orders. What is number of orders? Demand upon EOQ multiplied by J7, that is ordering cost. So, it is 3461. So, but initially we know the value of Q is how much? 1824. Okay. For this set of inventory holding cost and ordering cost, right, if you are ordering 1824 units, so the total cost is 3461. You see that there is no much changes whether you order 1802 or 1824. Now, look at the next scenario, the holding cost is same, you see I8, but I change the ordering cost. So, when I change the ordering cost, now EOQ is changing, EOQ is 1919. Now, the corresponding cost is 3684. Okay. For this set of cost, for our initial value EOQ which I got 1824, now the cost is 3689. You see the cost wise only 5 rupees difference is there. Okay. And similarly, for when the interest rate is go to 26% and the order cost is 30, we are getting another set of Q star. Q star is 3602. No, 1732. For that the cost is again only 3602. But instead of 1732, if you order our initial value 1824, again the cost is only how much? Approximately there is a 5 rupees difference. So, what we are learning, even though there is a variation in the holding cost and ordering cost, the total cost, there is no much variation in the total cost. So, what we are concluding that the EOQ model, that is 1824, the answer which we got is the robust. It will not affected by small changes in our ordering cost and inventory holding cost. I will go back to the presentation now. So, I have brought the output. Look at this, there are changes 192.30, this is EOQ, but look at the cost, this is 3461, here also 3461. The second scenario 3684, 3689, only 5 rupees difference. The third scenario 3602 and 3000, here also only 5 rupees is difference. Fourth scenario 3835, here it is remains same. So, what we are concluding that our EOQ model which we got 1824 is the robust one. As you can see from the table, the value of Q star appears relatively stable even with some variations in the cost estimates. So, based on these results, the best order quantity is in the range of 1700 to 2000. If operated properly, the total cost for the company's inventory system should be close to 3400 to 3800 per year. Instead of saying yes a single unit, so we can give the range of inventory, the range for the EOQ that can be given, the range for the total cost. So, this may be the more robust. This take care there is if there is any fluctuation in the ordering cost. And we also note that there is little risk is associated with implementing the calculated order quantity of 1824. What is that risk? For example, if the cold drink company implements an order quantity of 1824 cases by using the cost estimate of $32 per order cost and 25% for the holding cost, but the actual cost for order turns out to be 34 and the actual annual holding cost turn out to be 24, then the company experiences only 5% increase. This I am saying 24, 24 and 34. The difference is, see between these two, here 84 it is 89, there is only $5 increase in the total annual cost. So, it will not affect. So, the model which we have proposed was the robust model. The same thing can be understood with the help of this figure. When you look at this figure, see this, the total holding cost, it is somewhat flat here, okay. It is somewhat flat. It is because the increase in the total cost is very small. It is not like this. In case if the total cost curve goes like this, there is a sudden increase in total cost. Now this is a flat. So, this also indicates that the model is more robust. So, that is what we are saying. The EOQ model is insensitive to small variations or errors in the cost estimate. This insensitivity is a property of EOQ models in general, which indicates that if you have at least reasonable estimates of ordering cost and holding cost, we can expect to obtain a good approximation of the true minimum cost order quantity. So, we need not bother about if there is any fluctuation in the ordering and holding cost. Now, we can see the assumptions for economic order quantity. What are the assumptions? The demand is deterministic and occurs at a constant rate. The order quantity Q is the same for each order. What I mean is like this, the demand is constantly decreasing, the Q star, say economic order quantity, is same for each cycle. The cost per order is constant and does not depend on quantity ordered. The purchase cost per unit C is constant and does not depend on the quantity ordered, because many time the demand in practical, the demand also cannot be deterministic and the unit cost also will not be same, because when you order more cost there is a possibility of discount. So, if there is a discount, we can cover that kind of problem in coming lectures. So, the inventory holding cost per unit per time period is constant. So, the total inventory cost inventory holding cost depends on both cost of carrying inventory and the size of the inventory. Okay. You see that the ordering cost is not like this. Ordering cost is independent of size of the inventory, but the holding cost is directly proportional to the size of the inventory. Shortages such as stockouts or back orders are not permitted. What is a stockout? If the demand goes on negative side, that is not permitted. What is the back order? So, for example, the January order cannot be fulfilled in the month of February. That is the meaning of back order. The lead time for an order is constant. The inventory position is reviewed continuously. What is the meaning of this? Inventory position is reviewed continuously. We are closely monitoring the inventory level. As soon as it reaches the reorder point, immediately we are placing another order. That is the meaning of the inventory position is reviewed continuously. As a result, an order is placed as soon as the inventory position reaches the reorder point. Okay. So far we have seen about EOQ assumptions. Now we will take another problem. For that problem I will find out what is the EOQ, how frequently we should order, and what is the reorder point. So, the problem is like this: a bus company purchases diesel fuel from a petroleum supplier. In addition to the fuel cost, petroleum supplier charges the bus company $250 per order. So, we got the ordering cost to cover the expenses of delivering and transferring the fuel to bus company's storage tank. The lead time for a new shipment from that petroleum supplier is 10 days. Lead time is 10 days. The cost of holding a gallon of fuel in the storage tank is $0.04 per month. When you multiply by 12, so 0.48 per year. The annual fuel usage is 1,50,000 gallons. Annual demand is this much, but the company operates 300 days a year. So, what are the questions need to be answered? What is the optimum order quantity, EOQ, otherwise you can call it as Q star? How frequently should bus companies order to replenish the gasoline supply? So, we have to know the cycle time. The bus company storage tank have a capacity of 15,000 gallons. Should bus company consider expanding the capacity of storage? The next one, what is the reorder point? Okay. So, we should find out the following things. We should know what is the Q star, we should know what is reorder point, we should know what is the cycle time T. Okay. Now, what are the data is given? So, we know the annual inventory holding cost CH is 0.48, annual inventory ordering cost CO is $250, annual demand 1,50,000, lead time 10 days, number of working day 300 days. First we will solve this question. What is the first question? What is the optimal order quantity for the bus company, EOQ? We know that the total cost is annual inventory holding cost plus annual ordering cost. So, Q upon 2 0.48 plus 150,000 upon Q multiplied by 250. So, the value of Q is 12,500. This we can solve with the help of Excel. So, I will go back to Excel. To know the Q star, there are two ways. One, we can use our traditional formula. Otherwise, we can solve these equations by using concept of nonlinear programming. you will get a Q star. Now, how frequently should bus companies order to replenish the gasoline supply? To answer this, first you should know the number of orders. What is the number of orders? 150,000 upon 12,500 is 12. So, the number of order per year is 12. So, what is the cycle time? Number of working days upon number of orders. So, 300 is the number of working days per year upon 12 orders. So, every 25 days that company should make the order. So, what we have found like this. So, we know what is the Q star. What is the Q star? Q star is 12,500. So, what is the cycle time? Cycle time is 25 days. What is the number of orders? 12. So, like this 2, 3, 4. So, up to 12 the cycle is number of cycle is 12. So, up to 12 cycle we have to make it. So, every 25 days you have to place the order. The next question, the bus company storage tank have a capacity of 15,000 gallons. Should the bus company consider expanding the capacity of storage tank? It is not required, because our EOQ itself only 12,500. The tank capacity is 15,000. So, every time we are going to buy, we are going to store only 12,500 gallons. So, there is no requirement for expanding the capacity of the storage tank. So, what is the reorder point? Reorder point is lead time in days multiplied by per day demand. We know the lead time is 10 days, per day demand is annual demand divided by number of working days, that is a 500. So, 10 multiplied by 500, it is a 5,000. So, what we have found? We found what is the Q star, we found what is the cycle time, then we found what is the reorder point. So, our Q star is 12,500. When the demand reaches say 5,000, you have to place another order. How many number of orders? The number of order is 12. So, this is 25 days, like this there is a up to 12 times. Okay. Dear students, in this lecture I have explained how to use the concept of nonlinear programming for finding economic order quantity. Then I have answered when to order. Okay. What is the when to order? Then we found the reorder point. So, when the inventory reaches that point, we have to place another order. That is the answer for our when to order. Then we have found what is the cycle time also. What is the meaning of cycle time? How frequently we have to make the order, that we have found in this lecture. Thank you very much.